Welcome back, everybody. Let's take a look in AP Chemistry, and we're in our last section of Chapter 3. And this whole chapter has been about converting from one thing to another, using the mole, doing the stoichiometry and everything. Now we can take a look at a compound that has some water in it, and we refer to these as hydrates. And so there's a couple concepts with this one. Ionic compounds often separate from water. Solutions with molecules of water incorporated into the solid. So there's a little bit of water in there. And such compounds are referred to as hydrates. Certain hydrates lose all or part of their water of hydration. When they're exposed to air, they dry out or they're heated up, and we refer to that process as efflorescence. And so we can use that to figure out how much water is in there, and we can tell that the water is out because frequently dehydration is accompanied by a color change. So, for example, crystals of the hydrate cobalt 2 chloride with 6 molecules of water in it does change from a red to a purple in dry air. And this is used as an ingredient of invisible ink and other things. So writing only becomes visible when the paper is heated, driving out that water, leaving a blue residue. So just a common application, I guess, more than anything else. And so when we talk about compounds, we commonly refer to how much water is incorporated in with that by using the following prefixes. So it's mono, di, tri, tetra, pent, hex, hept, oct, non, and dec. So using that concept then, we would take a look and see that copper 2 sulfate would be copper 2 sulfate heptahydrate, barium chloride trihydrate, and magnesium sulfate pentahydrate. That's just the concepts behind those hydrates. And so then we see frequently questions like this. A certain hydrate of potassium aluminum sulfate, or alum, has a formula of KAlSO4 but we want to know how much water is in there. So what we're going to be doing in lab is we're going to heat up a sample and drive off all the water and then figure out kind of in reverse how much water was there. So let's take a look at how this process works. And again, we're going to be actually physically doing this in lab, so it's important to get this skill to figure out the mass percent of water and then figure out the empirical formula for the entire compound with the waters attached. So notice in this problem, we started out with 5.49 grams. Okay, so the entire compound, this contained water in there, and so we have 5.459 grams of the potassium aluminum sulfate with certain amount of water in it. Okay, so the entire compound is this. And when we drive it all off, we find that we only have 2.583 grams of just the potassium aluminum sulfate left. There's no water in there. So the question is pretty simple, 2.876 grams of water. Now, how can we use that to figure out the mass percent? Well, remember, mass percent is just what you got divided by the entire thing. So 2.876 grams of water divided by the entire sample's worth, which is 5.459 grams of sample, that's going to give me 52.88% water. All right, so that's the percent of water that we find in there. So the question is, how can we use this also to figure out how much water in terms of moles in at least the empirical formula? Now notice I used the keyword of moles. All right, so let's go back to the beginning and take a look, and now I've got my compound here. Okay, we said that we had 2.583 grams of the compound. So in this compound, we have 1 potassium, we have 1 aluminum, we have 2 sulfurs, and we have 8 oxygens. And so I'm just looking at the formula masses, and this is 39. So if I add this all up, I end up with 39 plus 27 plus 64 plus 128. So the formula mass of the entire compound is 258 grams. Okay, so taking a look, again, we're looking for the empirical formula, 2.583 grams of the compound, and I see that we have 258 grams per mole. All right, so that's going to give me 0.0 0.0100 moles of the compound. Okay, now we do the exact same thing for the water. Okay, we said that we had, um, looking back, we had 2.876 grams of water. Okay, we had that previously. So 2.876 grams of water, and water is 18 grams per mole. And so I see that I have 0.160 moles of water. Now remember what we do with empirical formulas, we divide by the smallest number of moles. Okay, smallest number of moles is going to be here, so 0.0100 divided by 0.100, and I end up with a ratio of one of the compound for every 16 waters. And so what's the empirical formula of the entire compound? The empirical formula for the entire compound is one of these for every 16 moles of water. There we go. And you don't have to be able to name that one. It's just 16 waters in that one because that goes beyond our 10 base 10 units. Okay, so that's the first one. Now let's take a look at another one. This will be our last one. So this is a short video, just taking a look at now the magnesium sulfate. Okay, this one they're telling us we already know it's a heptahydrate. Okay, so magnesium sulfate, magnesium is a +2 and sulfate is a -2. So it's written like this, and because they tell us it's a heptahydrate, that hept means 7, so I know that I have 7 waters. If I do all my math with this, or if I just look at the problem with this, I see a bunch of other things. I have 7.84 grams of the sample, and it's heated until basically all the water's been evaporated off. We want to know what the formula for the Epsom salts, and we want to know what the mass of the anhydrous magnesium sulfate would be once all the water's off. Okay, what is the percent of water? So looking at all of this, if I add up the entire compound, I see with magnesium and sulfate and my 7 waters in there, that ends up being 246.51 grams. Okay, just if I take a look at 7 of the waters, well, 7 times the 18, that gives me, leaves me with my magnesium sulfate just being 120.37 grams. Okay, that tells me that I had 126.14 grams of just the water. Okay, now the question is, how did I get all that? Well, within magnesium sulfate, I have 1 magnesium, and that's 24.3. I'm going to keep it at 24.3 for the entire mass rather than just 24. I have 1 sulfur, that's 32. And then I have 4 oxygens at 16, and that gives me 64. So that's where my 120.37 comes from. Okay, so it's assuming I have a mole's worth with that. And my water, remember that it's 2 hydrogens and 1 oxygen. That's 16 times my 7. That's where my 126 came from for my my water mass. Okay, so just pretty straightforward, and figuring out those. It's just figuring out a, I guess I just want to say a mole's worth of that. That's the formula. The mass of the anhydrous magnesium sulfate is provided there, and then I want to know my percent of the sample. So really what I do is I take a look, and I see that I have, if I do my percents, let's work this a little bit in reverse, I see that I had 126.14 grams of water. Okay, so I had that much water, but I had for the entire compound, I had 246.51 grams of the compound that's hydrated. So my percent of water ended up being a 51.2% water. Okay, that leaves me with 48.8% of my magnesium sulfate. Okay, so just taking a look at that. And the reason I wanted to do that because I wanted to know my percent of water in there, but I'm really trying to figure out how much magnesium sulfate would there be, the mass of the anhydrous with all of this. Okay, so it just says that I drove off the water, but it doesn't say how much of the magnesium sulfate. So if I know now I have 48.8% of the magnesium sulfate, I take a look and the sample itself started at 7.834 grams. Well, 7.834 grams times my 0.488, that's 48.8%, that will leave me with 3.825 grams of magnesium sulfate. So notice to approach problem 2, I had to actually look at problem 3 first. So I found out my formula masses. I found out how much water was actually driven off, and then I turned that into a percent, found the percent of my compound, and then applied it to what my original sample was. So I work kind of things in reverse, but that's essentially all you need to do when solving these types of problems. Okay, so that will give you enough to get equipped with the lab, and I wish you guys luck because in the future we're just going to be taking a look at wrapping up the chapter, and within this chapter we're going to be doing some NIMSY problems. Like I said, there's going to be lab application. Be ready for that on the test. All right, good luck to you guys, and we'll catch you in the next unit.